Hello and welcome to this chemistry video on the general properties of aqueous solutions. I've been following Brown, LeMay, Burston, and Murphy's Chemistry, the Central Science, for some time now. And chapter 3 was on stoichiometry, balancing equations and things like that. And so chapter 4, which this video begins, is titled Aqueous Reactions and Solution Stoichiometry. So we're going to look at the stoichiometry of solutions in this particular chapter. Well, let's talk about aqueous solutions. What is an aqueous solution? Well, you know, Aquaman, you know, agua in Spanish. It has to do with water. So an aqueous solution is a solution in which water is the dissolving medium. And you'll see this in a stoichiometric equation. You're going to see in parentheses AQ after such a substance to tell you this is in water. Now, there are other kinds of solutions. Of course, you can dissolve things in other things. Now, to back off of aqueous into a more general kind of nomenclature or wording, in a homogeneous mixture where everything is equally mixed together, the solvent is the substance present in the greatest quantity. So we call the thing the solvent that you're putting stuff in. The thing you're putting in that is in lesser quantity is called the solute. So other substances that are in the solvent are solutes. Solvent is the majority component. Solute is the smaller represented elements or compounds or whatever that's in the solution. Okay, so this video is mostly about definitions. It's not too hard on the brain. So what is an electrolyte? Sometimes you hear about electrolytes. Oh, you've run a marathon. You need to replenish your electrolytes. Here's a Gatorade. Not that I'm representing Gatorade. Gatorade is not giving me any money whatsoever for this video. As far as I know, if somebody from Gatorade wants to give me money, I will gladly receive it. Anyway, an electrolyte is basically a solution, well, something dissolved in there that's ionized. Let me start over here. An aqueous solution that contains ions is called an electrolytic solution, okay? So if you've got a stuff dissolved in water and the stuff has basically broken apart into its ions, the ions are an electrolyte and the solution is an electrolytic solution. What is an ion? What are ionic compounds? Well, these are compounds that are made up of a metal and a non-metal. And these tend to dissociate pretty readily in solution in water. They also that kind of solution where you have ions that have dissolved in water also tend to be very conductive, so they conduct electricity. So positive, negative ions. So an electrolyte is a ion that has been dissociated in solution or in water, okay? And that's an electrolytic kind of solution. Ionic compounds are therefore electrolytes when they dissolve in water, okay? Now, a substance that does not, okay, this is going to be tough. If a solution that dissolves into ions in water is an electrolyte, then a substance that does not dissolve into ions in water is a non-electrolyte. Okay. Boy, that's so hard. I need a rest. Let me take a drink. Okay, so electrolyte, it dissolves into ions in water. Non-electrolyte does not dissolve into ions in water. Molecular substances tend not to dissolve or disassociate into ions in water. You can have a little disassociation with molecular acids like acetic acid, but hold that thought. Okay, so electrolytes, as I said, conduct electricity. Non-electrolytes don't. Okay, right. So what is another electrolyte? An electrolyte is an ionic compound that dissolves into its component ions in water in solution. A non-electrolyte does not dissociate in solution. Okay, and now about the solvation of ions. We're going to save some ions. No, it's not about solvation. Solvation. Okay, this is about going into solution. Ions going into solution. So what happens when something dissolves, and by the way, we need to distinguish whether something is soluble, that is, it dissolves in water, and whether something is, say, electrolytic, because there are molecular compounds that dissolve, like acetic acid completely dissolves in water. However, it's not heavily ionic. So two distinct issues: whether something dissolves, and two, whether it's electrolytic and conducts electricity, and so forth. But anyway, when something dissolves in water, basically, well, if we're talking about ions, the ions separate and water kind of congregates around them. Like, ooh, can we touch you? You're important. And so you've got, like, if you have sodium and chloride, sodium and chlorine, you put sodium and chlorine in sodium chloride, which is salt, into water. It's going to break apart into its ions, and then the water is going to come and hang around it in circles and say, "Ooh, I want to touch you." And so you've got the chlorine water surrounding the chlorine ions, and you've got water surrounding the sodium. And this is called the solvation, not the salvation, but the solvation of these of sodium chloride. And the ions are said to be solvated. So they have separated apart as ions and have been surrounded by water molecules. Okay, and now bad drawings by Ken. So if these are little ions, so there's a positive ion, there's a negative. So let's say this is a sodium +1 ion, and this is a chlorine -1, sodium +1, chlorine -1. So these are little water molecules, H2O. So the O part, the oxygen part of a water molecule, leans negative, and the hydrogen of a water molecule leans positive. So if you look down here at the bottom, delta plus, what that's saying is that you have a partially positive charge. Maybe partial is not the right word. We have it leans positive in the hydrogens, and it leans negative in the oxygen, just because of the way the electrons tend to distribute in the hydrogen. So the electrons lean more toward the oxygen and away from the hydrogen in water. And so we say that we have a delta plus with the hydrogen, and we have a delta minus with the oxygen. And so they all line around. See, look there. Ooh, you're important. I want to be around you. And so we've got the water molecules surrounding. And notice that it's lined up by charge. So because the sodium ion is positive, you've got the more negative side of the water molecule hanging around. And this is what we mean when we say something's dissolved, or when we say an ion has dissolved. When a molecular compound dissolves, it doesn't break apart. It just, the waters surround the whole molecule. But anyway, okay, so here's a badly drawn example of this solvation. Okay. So we've been talking about ionic compounds. Ionic compounds are compounds where you have a metal and a non-metal, and they tend to be electrolytes that they completely dissociate. The sodium and the chloride have an amicable divorce, amicable separation, and water surrounds each one of them. Molecular compounds do not break apart like that in general. In solution, what happens is that the molecules disperse from each other, not the ions. In ionic solution, the ions themselves break apart and separate. In a molecular solution, the molecules are the things that separate if it's soluble. That is, if the molecule dissolves. So there are a few, and I said this, like acetic acid, there are a few molecular substances that do split a little bit into ions in solution. So you do get a little bit of the H plus of acetic acid separating a little bit from the other part. Not nearly as much as with electrolytes. So you have strong electrolytes and you have weak electrolytes. A strong electrolyte is one that when it dissolves, it completely breaks apart. A weak electrolyte is one where, well, I'm not sure I want to divorce you or not. I'm going to stick around a little bit. Horrible analogy. Please forgive me. This is personal. It's very important. Anyway, but so strong electrolytes completely or almost completely dissociate, break apart in solution. So like hydrochloric acid. Notice the AQ in solution in water. So hydrochloric acid, when you put it into water, it boom, completely disassociates. It doesn't explode. But anyway, although I mean, you could have a pretty strong reaction if anyway. But if you had a pretty concentrated bit. But so this is a strong electrolyte. It completely dissociates. And notice the arrow. The arrow is very strongly in one direction, representing the ionization of strong electrolytes, okay? On the other hand, weak electrolytes only partially dissociate. I mentioned acetic acid. So this double arrow back and forth indicates half arrows is what it's called. Half arrows in both directions indicates that it kind of goes back and forth. We're together, we're apart, we're together, we're apart, but we're not too far apart. So this is a weak electrolyte. It does, because it's acidic, it does dissociate a little bit in water, although this is a molecular compound. It tends to stay together. But there is a little bit of dissociation, and it kind of goes back and forth. It's a weak electrolyte. So like only about 1% of acetic acid will ionize in chemical equilibrium. I think that's it for this video. It is, but let me remind you again that whether something dissolves is a different question from whether or not it's a electrolyte that the ions dissociate. Two different issues. Electrolytes different from whether it dissolves. Well, this has been an attempt. Man, why is he doing these videos? I mean, really, on some general properties of aqueous solutions.